See, in vector calculus, you will study in two parts. One is vector differentiation. Okay. And second thing, vector integration. In vector differentiation, you will learn gradient, how to find gradient, what is the significance of gradient, I will tell you. Directional derivative, solenoidal and irrotational. Divergence and curl. Okay, and last topic is scalar potential. Okay, and these all topics are based on gradient. This is the basic things. Without gradient, you cannot learn all these. Understood? And in yes, and in vector integration, you will learn line integral. In this topic, all things are depend on integration, and in this topic, all things are depend on differentiation. So line integral, Green's theorem, Stokes theorem, and Gauss divergence theorem. Okay, Gauss divergence theorem. So one by one we will discuss. Okay, these four topics are depend on integration, and all these topics are depend on differentiation. That's why you can say this is vector differentiation part and this is vector integration part. Understood? Yes. Now we start from gradient. What what is gradient? You know what is gradient? Anything? Yes. 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 Okay. See, gradient is nothing but a operator, right? Gradient is a operator which which change a scalar function into vector function. Understood? Yes. In vector calculus, the gradient of scalar gives the direction of the maximum rate of increase that function. Understood? See, there are two types of function. Let's suppose this is xyz and this is xi, yj and zk. Tell me what is difference between this function and this function. Very good. Because uh, vector is identified by using I, j, k, and k component. And in the first one, there is no I, j, k component. That's why this is scalar function and this is vector function. So if anyone asks what is gradient, you can tell gradient is an operator which changes scalar function into vector function. Okay. Yes. And gradient is what is the operator? This is the operator. I del y del x del y plus k del y del y. This is the value of that operator. Right. So how a scalar function is changed into vector function by using this formula. Gradient phi. You can write vector phi. That's why I write in vector form. And this is not vector. That's why I write in simple phi form. Right? Yes. So when you multiply phi on both sides, you will get what? This. Yes. This is nothing but a gradient of phi. In short, you can write grade phi. And grade phi, you will find the value of grade only when phi is scalar. And grade phi becomes a vector. Okay. The result of grade phi becomes a vector phi. I show you how. Understood this? Okay. I'll check it. Hello. Understood? When a scalar function is changed into vector function using grade phi, right? It is called grade phi. For example, suppose you want to change this function into vector function. Then how will you change? Just find its grade phi. What is the formula? Okay. Put the value of phi. What is phi? X, Y, Z, X, Y, Z, X, Y, Z. See, when you differentiate partially with respect to X, what will you get? YZ with respect to Y, XZ, and with respect to Z, XY. And this is what? Gradient phi, or you can write vector phi, write in vector form. Okay. Yes. Now you understood why we study gradient. Gradient is an operator which change a scalar function into vector function. Okay. I am telling function. Why function? Because your result comes in the form of variables. This is a vector value. Why? Because there is no variable. This is simply vector. But this is vector function. Let's suppose 2xi, 2yj, 3z square k. This is vector function. Understood? Yes. Okay. Can I delete this? You? Okay. Find the gradient of phi is equal to x square y plus z cube at 1, 1, 2. Okay. So you are going to find what? Gradient of phi. Gradient of phi means what? Grade phi. And grade phi is nothing but a multiplication with del operator, right? Del phi by del x, del phi by del y, del phi by del z. And what is phi? Phi is x square y plus z cube del x square y plus z cube. Right. Now tell me what is the differentiation of this part with respect to x? Y. And z cube is 0. With respect to y? With respect to z? Right. Grade phi, also you can write grade phi, right? But you have to find at point 1, 1, 0, oh, sorry, 1, 1, 2. So you can write grade phi, or you can write vector phi at 1, 1, 2. So you will get what? 2. 1 square is 1 and this becomes 12. Right now, because z is 2, 2 square into 3. So finally vector phi at 1 1 will be 2i plus j plus 12k. Understood? Yes. Can we move? Yes. Now I tell you this is gradient. Okay. Now I tell you a directional derivative. Can you tell me the question, answer of this? Basically, you are asked to find the gradient of this. Here it is not written gradient, but you can understand vector phi is nothing but a gradient of phi, right? So tell me the gradient of phi at 1 1 1. Yes, tell me. Right. Okay. Understood? Yes. Okay. Now I tell you what is directional derivative. So directional derivative is what? Directional derivative of a scalar function phi tells the rate of change of phi in any specific direction. Okay. So directional derivative is what? The rate of change. The rate of change of any function phi in direction of vector u. Okay. Vector u is any type of vector. So how to find directional derivative? Directional derivative of phi in the direction of, this is the formula actually I am writing, in the direction of vector u is what? Gradient of phi dot unit vector of u. Right? You know how to find unit vector? Vector upon its magnitude. Right? Yes. I show you with one example. Okay? Yes. Now see, this is my question. Find the directional derivative of x square plus y square plus z square at 1, 2, 3 in the direction of 3i plus 3k. Okay. Now first you identify and tell me what is vector phi, sorry, what is phi and what is vector u. Very good. So far 5, you have to find what? Gradient 5, right? And this is vector u, 3i plus 3k. What is modulus of vector u? Root 18 means 3 root 2, right? Yes. Okay, now you got vector u. That is, right? Okay. One part you got. Now we will find gradient of phi. Understood? Yes. Gradient phi is what? X square plus y square plus z square. You can write directly, right? But always try to write in systematic way so that for better performance, right? Okay. So with respect to x, 2x, with respect to y, 2y, and with respect to z, 2z. At which point? 1, 2, 3. So 1 means 2i, 4j, and 6k. Now use the formula. What is the formula? The directional derivative of phi in the direction of vector u is gradient phi, right? So directional derivative of phi along vector u grad phi dot u. Sorry, unit vector of u. So grad phi is what? And dot product is what? I. There is no j component, so you can write 0j, right? Why I am writing in this way? Because in dot product, corresponding element are multiplied. I is multiplied with I, j is multiplied with j, and k is multiplied with k, right? So 2i into I is what? 2. 4j into 0j is what? 0. 6k into 1k is 6 upon root 2. 8 root 2. 8 root 2. Either you can leave here or you can further simplify. But this is your final answer. Understood? So whatever vector you have given, first find its unit vector, and whatever phi function is given, you have always given a scalar function. Then find its vector function and take dot product. You know how to find dot product? Yes. I think you understood. Yes. So first find gradient phi, substitute the given point, convert the directional vector into unit vector, and take the dot product. Right? Yes. So before going further, I tell you, I want to revise your concept vector product because you will get somewhere. There are two types of vector product: dot product and cross product. Suppose you have two vector a1i, b1j, c1k. A1, A2, A3, B1, B2, B3. For dot product, you will have only corresponding elements are multiplied with each other. Okay. In dot product, I dot I, J dot J, and K dot K is always 1, otherwise 0. Understood? In cross product, right. I will be, right? Okay. Now you can observe one thing what? I cross I, J cross J, and K cross K is 0. Otherwise, I cross J is what? K? Yes. J cross K is what? I. K cross I is what? J. Because this is in cyclic nature. You can observe one thing what? The result of dot product is simply a vector scalar. There is no ijk component, right? That's why this is called scalar product. Why scalar product? Because the product in product final result is in scalar value, a constant. While in cross product, you can observe one thing what? Your result comes in ijk form. Ijk form is also called vector form. That's why this is called vector product. Understood? Yes. Right? Yes. Noted? Find the directional derivative of in the direction of 2i minus j plus 2k. Can you tell the answer of this? Yes, tell me. 1. Okay. Let's check. Grade 5 will be this is 2xy and x square plus 2y, is it right? And k will be y square. So at 0.111 it will be 2i 3j plus k. So directional derivative will be 2 into 2, 4 minus 3 plus 2 upon 4 plus 1 plus 4. Yes. Yes, 1. Okay. Yes. Okay. From A to B. Okay. Then how will you solve this? Phi is 0 and grade 5 will be same. Only you have to find vector u. How will you find vector u? See, from 1 to B, sorry, from A to B. Then vector u will be B minus A. 2 minus 1 is 1. 3 minus 2 is 1. 0 minus 3 is minus 1. That's it only. Now you have vector u. Right? So directional derivative will be u is what? I plus j minus 3k upon root 11, which is equal to 2 plus 3 minus 3 upon root 11. 2 by root 11. So the rate of change of function with respect to that vector is 2 upon root 11. Right? Yes. Understood? Okay. See, prove that x square plus y square plus z square and vector v is equal to tan inverse y upon x is orthogonal. So you have given two function and these function are scalar function, right? And you have to prove that they are orthogonal to each other. And you know what is orthogonal? Perpendicular. Two vectors are perpendicular means two vectors are orthogonal to each other, right? Yes. So how will you do this? You know, two vectors are perpendicular or orthogonal only when, see, suppose U and V are orthogonal, their dot product are zero, right? You know this concept? Okay. If two vectors dot product is zero, then their vector A is perpendicular to vector V. But this is not vector actually, right? This is scalar function. But you can make this into vector. How? By finding gradient U. So find gradient U. This is what 2x, 2y, 2z. This is vector U, right? Okay. Now we will find for vector V. You can see there is no z component. And with when you do with respect to x, tan inverse x is what? Y is constant into minus 1 upon x square, right? With respect to z, into 1 by x, right? And this is a constant. On again simplification, minus y upon x square, do cross multiplication, x square plus y square upon x square. Okay. You can see this is cancelled. Here this one part is cancelled. So minus y upon I x upon. Okay. So vector u, if vector u and vector v perpendicular are orthogonal, then their dot product must be equal to 0. So vector u is what? 2xi, 2yj, 2zk. And what is happening in dot product? I is multiplied with I, and j is multiplied with j, and there is no k component. Both are same thing with opposite sign. They are cancelled with each other, right? Therefore, you can say vector u and vector v are orthogonal. Understood? Orthogonal means perpendicular. They are perpendicular only if their dot product is 0. But the problem is that they are not vector. First, make them into vector and then take dot product. Right? I think you understood the concept of gradient and directional derivative. Yes. Do you have material on this topic? Yes, send me the question so that I can explain that question and you can understand those. See this question, question number 6. Right? It's very easy. So all this part you can do from up to 11. You can do everything. Okay. But I show you how to solve 6 1. See, before 6, I will tell those also. Don't worry. See, you have to find the gradient of 1 upon r. Right? Basically, you are finding what? Let's suppose 1 upon r is 5. And what is 5? What is r? R is nothing but modulus of vector r, right? And what is vector r? This is position vector. This is called position vector. So, yes, x square plus y square plus z square. Right? Yes. Okay. So, before going further, you can find here root x square plus y square plus z square. When you do with respect to x, what will you get? You can write, can you write in this way? With respect to x becomes what? X square plus y square plus z square minus half minus 1 minus 3 by 2 into 2x. 2 cancel. X square plus y square plus z square minus 3 by 2, isn't it? If x is replaced by y and y is replaced by z and z is replaced by x, is there any changes in the function? No. This is called symmetric function. Okay. Whenever you have symmetric function, just only find with respect to x and you can write directly. For with respect to y, how? Put r, you can do replace x with y with z and z with x. So here x is there, so you can write here y minus 3 by 2. Similarly for with respect to z will be y will be replaced with z. Okay. Up to here you understood? Okay. Now gradient 1 by r will be gradient, or you can write directly I, right? Where phi is what? 1 by r. And 1 by r is this. And you have already find this I minus x minus z x square minus 3 by 2. Okay. Okay. You know, vector r is xi, yj, and zk. And what is r? Right? Then r square will be, isn't? You can see one thing what? This is minus xi, and this is what? R square, right? So here you replace r square with, this is also r square. So these two cancel, right? And take minus outside. You will get, okay, uh, r cube xi, r cube yj, r cube zk, right? Take r cube common, xi, yj, and zk. This is basically what? Vector r, right now? This is in vector form. So your final answer will be, oh, minus r, minus 3 is there, right? And this is vector r. So minus power means what? Minus vector r upon r cube. And this you had to prove. So gradient of, yes, this is what you want to prove, right? Vector r upon r square. I think here r cube is there. There is some mistake in the question. This will be r cube, not r square. Okay? Yes. So this is your required proof. Understood? Yes. See, this question number 9 is very good question. Question number 8 you can do, and we have discussed already, right? Yes. In question number 9, find the directional derivative of the function. Function is what? At 1, 1, 2. In the direction of vector u is grade for f. Okay? Okay. You understood the question? Okay, now we will find. See, first we find grade f. Grade f is what? When you do with respect to x, you will get 2x. With respect to y is what? 2y. And with respect to z is 4z. Okay. At 1, 1, 2. So 2i, 2j, 8k, right? This is grade 5, and this is what? Grade f also, right? Okay. $74. So directional derivative of f in the direction of vector u. Vector u is nothing but grade f. Okay, will with unit vector of u. So grade f is what? 2i, 2j, 8k dot product with vector u upon root 74. 4 plus 4 plus 64. 74. So root 74. Right? Yes. This is your final answer. Can you try this? 8 1. Yes, tell me.